Once we know how to simplify radical expressions, we also want to look at how to add, subtract, multiply, or divide radical expressions. This segment deals specifically with adding or subtracting them. I have 3 different examples, but first let's go over what the process is to add or subtract radicals. Now, to add or subtract radicals, they must be like radicals. That means they must have the same index and the same radicand. So it's very much like the thought process in terms of when we were adding or subtracting polynomials. Remember, we had to have like terms. With radicals, we have to have like radicals. You then add or subtract the numerical coefficients of the radicals, but then you keep the radical part. Adding or subtracting is like seeing the combination of how many of those things you have. So let's look at our first example. Our first example is to take 5 cubed roots of 7, 5 times a cubed root of 7, and add to it a cubed root of 7. So the overall operation between is to add them. And I have a term that is 5 times the cubed root of 7 and a term that's the cubed root of 7. Within these 2 terms, they do have the same radical, cubed root of 7. So I've met the condition that they have like radicals, and now I want to add them. Well, 5 cubed roots of 7 plus another cubed root of 7 overall will give me 6 cubed roots of 7. So I added the numerical coefficients. Remember, if you don't have a numerical coefficient showing, it's an assumed to be a numerical coefficient of 1 with my plus. So 5 plus 1 is my 6 cubed roots of 7. Okay, next, let's look at 6 times the square root of 11 minus the square root of 11. So here, I can't simplify the square root of 11 anymore. 11 is prime, so there's nothing that can come out of the square root. And I'm to subtract these 2 separate terms. I have 6 square roots of 11 minus 1 square root of 11, so that gives me 5 square roots of 11 for my simplified answer to that subtraction. Okay, let's look at this third example. Here, at first look, I have 7 times the cubed root of 24 plus 5 times the cubed root of 3. I cannot add these 2 radicals the way they're currently written. Now, my hope is that if there's either of these terms that have radicals that are not simplified, that maybe in the simplified form I do have like radicals, and then I would be able to carry on the addition from there. So let's look at our first term. Our first term is 7 times the cubed root of 24. I want to break apart 24 into its prime factorization under that cubed root to see if I have 3 identical factors of any factorization within there so that I could free that number out and then see what the simplified form is. So let's just look at 7 times the cubed root of, well, 24 with its prime factor tree. 24 is 2 times 12. 2 is prime. 12 is 2 times 6. 2 is prime. And 6 is 2 times 3. 2 is prime and 3 is prime. So underneath the radical, I'm going to replace the number 24 with its prime factorization. 2 times 2 times 2 times 3. Now let's just bring down plus 5 times the cubed root of 3 as we go along so we don't lose what the whole problem was. Now underneath the cubed root, I have an index of 3. So if I have 3 identical factors of any individual value, then I get to bring that number outside the radical. And if there's a number that's multiplied to the outside of the radical, anything that I bring out gets multiplied to that number. So here I have 1, 2, 3 factors of 2. So a 2 comes out, and it will be multiplied to the 7 that's already out there. I only have 1 factor of 3, so that needs to stay under. So this gives me 2 times 7 is 14 times the cubed root of 3. And I'm adding that to 5 times the cubed root of 3. Now when I look again, I see my first term is 14 times the cubed root of 3. It has a radical factor of the cubed root of 3. And my second term is 5 times the cubed root of 3. It has an irrational factor of the cubed root of 3. So the radical factors in each of these 2 terms match. They're like radicals. So to carry out the addition, I'll add the numerical coefficients and keep the radical part. So 14 plus 5 is 19, and then cubed roots of 3.